Hey everyone, and welcome. Today, we are going to talk about turning those simple lines of code you're writing into some seriously powerful programs. We're going to focus on two fundamental building blocks that will completely change the way you write Python. I promise your code is about to get cleaner, smarter, and way more powerful. So let's dive right in. You know that feeling, right, where you look at your code and it just feels messy? You find yourself copying and pasting the same chunk of code over and over again. It's a super common problem. But thankfully, there are some really elegant solutions that don't just clean things up, they make your code way more capable. And our first solution is one of the most important ideas in all of programming: functions. You can think of these as the ultimate tool for getting organized and being efficient. It's all based on a simple idea programmers call "don't repeat yourself," or, dry. So what in the world is a function? Well, it's just a named block of code that does one specific job. Imagine you have a killer recipe for a smoothie. Instead of writing down the ingredients and steps every single time you want one, you just grab the recipe card, right? A function is exactly that, but for your code. Okay, that sounds great in theory, but how do we actually build one? It is way simpler than you might think. Let's break down the basic structure. There are really just three key parts. You always start with the keyword def. That's you telling Python, hey, listen up, I'm defining a function. Then you give it a good descriptive name followed by parentheses. And those parentheses, that's where you'll eventually put the ingredients your function needs to work. And finally, and this is so important in Python, all the code that belongs inside that function has to be indented. Let's look at a real example. Here, we're defining a function called greetUser. See how it takes one piece of information inside the parentheses? We're calling it name. The function's only job is to print a greeting using whatever name it's given. Then, down below, we call the function, which is just a fancy way of saying we run it. We give it Alice, and it works. We give it Bob, and it works again. We just reuse that same logic without rewriting a single thing. Now, I mentioned indentation is crucial, and I was not kidding. In Python, it's not just there to make things look pretty. It actually defines the entire structure and logic of your program. This slide shows you exactly what I mean. We have the exact same lines of code on both sides, but they give us completely different results. Why? On the left, both print statements are indented, so Python knows they both belong to the function. But on the right, print world is not indented, so Python thinks it's completely separate from the function. That tiny little spacing change completely rewires how the program runs. It's a big deal. Okay, so think of our function like a little machine. You don't just want to put things in. A lot of the time, you want to get something useful out. Functions can do calculations and then hand a result back to your program, and they do this using the return statement. Check out this add numbers function. It takes two numbers, adds them up, and then here's the key part, it returns the result. This is so cool because it means we can call the function and actually save its output in a variable, just like we're doing here with someone. The function does all the heavy lifting, and our main program gets the final answer to use however it wants. And get this, it's even more flexible than that. You're not limited to returning just one thing. This function calculates both the area and the perimeter of a rectangle, and then it returns them both at the same time. We can then just neatly catch those values in two separate variables. I mean, how clean and efficient is that?
All right, so functions solve the problem of repeating yourself. Awesome. But what if you need to do something multiple times in a row, but only, while a certain condition is true? For that, we need our second major tool, loops.
So meet the while loop. Its job is actually pretty simple. It checks a condition, and if that condition is true, it runs a block of code. Then it checks again. And if it's still true, it runs the code again, and again, and again, for as long as that condition stays true. Think of it like an assembly line that just keeps on running as long as the power switch is flipped on.
But this power, it comes with a pretty serious warning. If that condition never becomes false, you create something that every programmer dreads, an infinite loop. Just look at this code right here. We set x to 6. The loop asks, is x greater than 0? Yup, it is. So it prints 1. Then it checks again. Is x still greater than 0? Yes. We never actually change the value of x anywhere inside the loop. So that condition is going to be true forever, and our program will just get stuck right there. So the takeaway here is absolutely crucial. You must have something inside your loop that will eventually make the condition false. Here, in our countdown timer, we subtract 1 from the countdown timer every single time the loop runs. Sooner or later, it's going to hit 0, the condition countdown timer greater than 0 becomes false, and the loop stops. That lets our program move on and finally print liftoff.
While loops are fantastic when you're waiting for some condition to change, but what if you have a collection of things, like a list, and you just want to do something to every single item in that collection? For that job, there is a much, much better tool.
This is the for loop, and it is built specifically to go through sequences. So here we have a list of fruits. The for loop just automatically works its way through it, one item at a time. In the first pass, the variable fruit is apple. In the next pass, it's banana, then cherry. The loop handles all the work of moving from one item to the next until it's done. It's clean, it's super readable, and you don't have to mess with any counters.
But what if you don't have a list? What if you just want to repeat an action a specific number of times? Like, say, 5 times. For that, we use the range function. Calling range 5 basically creates a sequence of numbers from 0 up to 4. So when you write for I in range 5, you're just telling Python, hey, run this loop exactly 5 times. It's perfect for when you need controlled repetition. So which one should you use? The rule of thumb is actually pretty simple. You use a while loop when you're looping based on a condition, like keep going until the game is over. And you use a for loop when you have a specific collection of items, like a list of users, and you want to do something for every single one of them. And just like that, you have unlocked 2 huge new capabilities in your coding journey. And these aren't just little tricks. These are fundamental coding superpowers. Let's do a quick recap of what's in your new toolkit. You've got functions so you can write clean, reusable, organized blocks of code. You've got while loops to repeat actions as long as a certain condition is true. And you've got for loops so you can effortlessly go through every single item in a sequence. Honestly, these building blocks are the foundation for almost any complex program you can possibly imagine. They let you go way beyond simple one-off scripts and start creating things that are truly dynamic and powerful. So the only real question left is, what are you going to build first?